Hello everyone, welcome to my YouTube channel. Today in this video we are going to discuss about the setting of pushover load case in Perform 3D. In the Perform 3D in analysis phase we have to define the analysis phase from setting of the load cases. First one is the gravity, second one is the pushover and dynamic earthquake. Similarly response spectrum, on-load pushover and dynamic force. We have the option to select each type of load. So in the previous video, we have already discussed about how to set out the gravity load cases in Perform 3D. So today we are going to setting up the load cases, static pushover load cases. So for this, select static load pushover load case. For example, select give the name suppose 0.25% H1 direction. Let me click OK. Then we see the dialog box. Here analysis method is nonlinear and the load type is nodal load pattern, displacement pattern and mode shape. So we can push the structure based on three types. The first one is nodal load pattern. The structure is pushed on the node assigned to the structure, and second one is the displacement load pattern, and it is controlled by drift. That lateral load is applied in the form of unit displacement, and third one is based on the mode shape, based on the mode shape of the structure. So let me go for nodal load pattern. Here first of all I have to go for control information for nonlinear analysis. Let me keep number of load step as 50. Maximum event is 200 in any step. Suppose for example my initial step to first event as no, so maximum allowable drift is 0.0025. It means 25 0.0025 means 0.25 percentage. The control deformation is, suppose let me go for control by drift. It is along the h1 direction, so it is along h1, so select d1. Here we have to define the nodal load pattern and go for the load pattern to be added or changed. Here there is no any nodal load pattern. For this let me cancel this one and we have to go for modeling phase, apply the nodal load pattern. Here for now there are no any nodal load, so let me click a nodal load here, and the number, select one or more nodes. We can select any nodes, suppose here one or more nodes, and let me give the unit force here because the structure have to be pushed by unit displacement or unit of nodal force. So replace the existing load, test, and okay. So after that save the structure. Let me go to same case, static pushover. Give me name plus 0.25 percentage h1 and click OK. Then number of load step, let me keep 50. Maximum event in any step is 200. Initial step to first event as click no, and uh, the maximum allowable drift. So now let me keep 0.25. It means 0.025, which is, let me keep as 2.5%. We can keep as 0.03. It means 3%. And here we have to go for nodal load pattern. Select the nodal load scale factor of 1. It means positive h1 direction. And if we have to select for go for negative h1 direction, we can keep the scale factor as -1. And by this way, like this way, the structure is pushed up to a control drift of 3% in positive h1 direction, and we can change it in S2 direction as well for both positive and negative pace, in which the scale factor have to be changes with the positive or negative sign for the case of static pushover load case. And in the case of cyclic pushover load case, we'll discuss more about that in another lecture series. So for now, this is the way the nodal load patterns for static pushover analysis can be done and structure is pushed up to the 3% level and the pushover curve of the structure can be obtained. So let me click save. And another one is the displacement load pattern. Here, let me define another one. Suppose h1 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 direction push. You can give any name. Okay, go for displacement load pattern. If the load case is based on the displacement pattern, first specify the displacement pattern over the height of the structure. For a displacement pattern, choose the base and the roof level of the structure as indicated here, and from 0 to 4 intermediate level, or here it is 0 to 6 intermediate level. The number, we can define any number inside the into the range of this level up to 6 level here, and specify the v coordinate and h1 and h2 displacement at each level. For a uniform pattern, specify the same as displacement at the base and the roof level. For a linear pattern, specify 0 displacement at the base and unit s displacement at the roof. The b coordinate must be in the structure coordinate system and the structure length unit, and the s displacement, which indicates h1 and h2, are relative value only and do not have units. For each mass in the structure, the h1 and h2 loads are proportional to the mass multiplied by h1 and h2 displacement respectively. So let me go select the displacement pattern. Here everything is same as previously defined, and in the case of displacement pattern, b is the coordinate. Suppose we have the assign the drift control drift in the base as well as the top of the structure. So like this, we have to assign the coordinate of the b. For example, this b is the base of the structure, and this b is the base of the structure is first of here, and top of the structure is the z coordinate is 12 meters. So the coordinates of V are 0 and 12, in which the drift D1 and D2 are assigned in drift section of the modeling phase. And displacement along H1, let me keep at the base of the structure, it is 0, it is 1 at the top, and along D2 direction, it is 0. Then let me click OK. Suppose if you have to push the structure along negative h1 direction, here the displacement along h1 direction should be negative. For example, let me click save as negative h1 direction. It means only we have to change the sign which push the structure in negative h1 direction. And if we have to push the structure in, suppose positive h2 direction, we have to change the displacement along h1 and h2 as 0 and 1. And if we go for negative h2 direction, we have to keep the scale factor of -1 here, and we have to select the drift d2 in h2 direction. We have to uh, coincide the drift so that the pushover analysis can be controlled by the drift to stop the analysis. So let me click OK. And another one is the plus h1 mode 1 based on pushover analysis based on mode shape. So we have to click on here mode shape. So if the structure is pushed on the mode shape or modal pushover analysis, specify the pushover direction and the modes to be used, a scale factor for each mode, and a base shear direction for each mode. For explanation, use the mode shape based on the load. So if we choose the load based on the mode shape, and if we use more than one mode shape, we must specify a scale factor for each mode. Only the relative value of the scale factor are important, since concern is the load distribution over the building height, not the load magnitude. So consider the first case of a symmetrical 3D structure with mode shapes that are clearly oriented in H1 and H2 direction. The following procedure are suggested. First of all, the mode shape and the modal period of the structure is evaluated, which must run the for that we have to run the analysis and define the pushover load case. So, so here for first mode, let me keep these things same, and it is positive h1, so the control drift is d1. Suppose let me keep the angle 0 for now, and for the mode shape it is mode 1 along the positive h1 direction. And if we go for mode 2, we have to give the scale factor here according to the mode shape. At some place it is positive and at some story level it is negative. So we have to clearly assign the mode shape according clearly assign the scale factor according to the mode shape, and for other modes do according to the mode shape. So for now the first mode is, let's say, positive d for a factor of positive 1. It means suppose we have the first mode shape of like this is positive 1, this is the first mode shape, and if we have a mode shape of like this, here up to this level, in the intermediate level the scale factor is positive, and after this point up to this level, either 2 3 or whatever be the story, the scale factor is negative for mode case 2. And for if we have the mode case of like this one, the scale factors should be applied according to this mode shape to the structure to run the pushover analysis. So with this way, the pushover load case can be set in the structure, and after this, in the next video, we will go for the definition of load cases series and run the pushover analysis, and we will see the pushover curve. Till then, keep watching. Don't forget to share, subscribe, and comment my YouTube videos. Thank you.